Have you ever felt like you're just, drowning in the vast ocean of web development tools? It's so easy to get lost, constantly configuring things or just struggling to squeeze out that last bit of performance from your backend. It's a common pain point, right? Can be pretty exhausting. So today we're taking a deep dive into something that, well, it promises to cut through a lot of that friction. We're going to explore UnJS. It's this collection of JavaScript utilities designed to simplify web dev, and specifically, we're zeroing in on one of its brightest stars, Nitro. We've pulled together a whole stack of interesting sources to help us navigate this universe of tools.
Yeah, and our mission today really is to cut through all that complexity you mentioned. We want to uncover how Nitro is genuinely revolutionizing server-side JavaScript. What features does it offer? How does it actually work under the hood? And maybe most importantly, why is it gaining so much traction? Why are developers talking about it? Think of this as like your shortcut to getting up to speed on this really powerful, but actually pretty accessible tool.
Okay, let's unpack this then. We hear about these huge JavaScript ecosystems all the time. It can feel overwhelming. But our sources describe NJS differently. They call it agnostic, built on a Unix philosophy. That sounds a bit, philosophical for code. What makes UnJS special in this, super crowded space?
That philosophy is actually key. It's fascinating how it translates into practical benefits.
Yeah.
Imagine building with high-quality Lego bricks. Each piece does one thing really well, right? But they all snap together perfectly. That's sort of the UnJS idea. High-quality, single-purpose packages. And they're designed to be collaborative, welcoming, and consistent across different JavaScript places. Node.js, browsers, edge runtimes, you name it. So it's not just some random pile of tools. It's meant to be a unified universe of components that work together. And the numbers, well, they kind of speak for themselves. You mentioned traction. Over 50 packages, something like 49,000 GitHub stars, and get this, 421 million monthly downloads across the whole ecosystem.
Wow, 421 million.
Yeah, that really points to a community that's embracing this modular, unified way of doing things.
Okay, those numbers are definitely impressive. But 50 packages, even good ones, can still feel like a lot to wrap your head around. So what does this mean if you're trying to figure it all out? Is there a map for this universe? Dependency hell is still a thing, right?
Right, exactly. And that's a really important question the UnJS team thought about. How do you navigate this growing collection? That's where this tool called UnJS Relations comes in. It's basically that map you're asking for. It's a visual graph. You could pick any UnJS package or even just a regular NPM package, and it shows you what it depends on. But what's really cool is it also shows you what other packages are using the one you selected.
Ah, okay. So you see both sides.
Exactly. You see the whole network, how it fits in, who's actually using it. It's a really powerful way to visualize these complex systems and, make better choices.
That sounds super useful. Okay, let's zoom in now. Nitro. Our sources call it a universal server toolkit. And significantly, the server engine for Next v3. That's a big deal coming from Nuxt. So what exactly is Nitro and why is it making waves in server-side JS right now?
I'd say it's genuinely revolutionary because it tackles that core problem of unifying server environments. It can work as a standalone server, for building just back-end APIs. But its real power, maybe, is as the engine inside full-stack frameworks. Like you said, Nuxt 3 using it is a massive endorsement, shows it's production ready. If you look at the big picture, Nitro's goal is to shield developers from the complexities of building fast, scalable server apps that need to run, well, anywhere. And it does this by building on top of H3. H3 is described as this minimal, super performant HTTP framework.
Okay, H3.
Yeah, think of H3 as like the stripped down, super efficient engine block in a car. It just handles raw HTTP requests and responses incredibly fast. Nitro then builds the whole car around that engine, adds all the features. Universal deployment, file system routing, code splitting, the whole developer experience package, all powered by that really fast H3 core.
So it's less like another web framework and more like a foundational layer, like a universal adapter for server code. That feels like an important distinction.
Exactly. It's all about abstraction and portability, making your code run wherever you need it.
Okay, one of the big promises here is making developers' lives easier. Always good news. Our sources highlight some key features. Let's dig into a few. First up, zero configuration. That sounds like, music to my ears after hours spent fighting with Webpack configs in the past.
Oh, absolutely. It really is.
Yeah.
Setting up a new Nitro project takes virtually zero config to just get going. You can literally create a project, write a bit of code, and run it. That's a huge win for DX, developer experience.
Yeah.
Because we all know how much time can sink into just the initial setup, right? the boilerplate. Plus, and this is a nice bonus, you get TypeScript support right out of the box.
Oh, nice.
Yeah, so you get type checking, better tooling, fewer silly errors without having to config or module resolvers just to make the server start. It just works.
Sounds incredibly smooth. So you've got it set up easily. Where can you actually use it then? Is it tied to a specific cloud? Or does it live up to that universal name?
It really does live up to the name. That leads right into another standout feature, universal deployment. This means you write your code once. Then you deploy it to, well, almost any hosting provider or runtime you can imagine.
Yeah.
We're talking Node.js servers, serverless like AWS Lambda, edge functions on Cloudflare or Vercel, even service workers in the browser.
Wow, okay.
Nitro's pretty smart. It looks at your code and builds different output formats tailored for these platforms. It has built-in presets for the big ones, Vercel, Cloudflare, AWS Lambda, Netlify, and so on. And even better, it often has zero config auto detection for platforms like AWS Amplify or Netlify. It just figures it out during your CI/CD pipeline.
So it smooths out the deployment part too.
Yeah, it's like having this universal plug adapter for your server code.
Yeah.
It's compatible almost anywhere, fighting that vendor lock-in.
That flexibility is huge. And it sounds like Nitro also focuses hard on optimizing the actual development process, not just deployment.
Yes, and this is where it gets really interesting for just like day-to-day coding. Nitro includes auto imports. This is powered by another UnJS package called unimport. What it means is you often don't need to manually write imports and util from utils everywhere.
Ah, okay. It just finds them.
Exactly. Nitro sees you're using some util and it handles the import automatically behind the scenes. This cuts down so much boilerplate code, keeps things cleaner, less mental overhead just managing imports.
Yeah.
Combine that with tree shaking, the process that removes unused code.
Right, like pruning dead branches.
Perfect analogy. It intelligently removes anything you're not actually using from the final build. So your deployed code stays lean, efficient, faster load times, lower costs. It's all about reducing clutter and boosting performance.
Less setup, less typing, more power. That sounds like a winning combo for developer happiness. What about structuring the actual backend, your API routes? Is it the old way or something new there too?
It simplifies that too using what they call file system-based routing. It's super intuitive, especially if you've done any front-end framework development recently. You just create a file and say an AB or routes folder. The file path becomes the route. So if you make route users.get.ts, boom, that's a GET endpoint at users.
Simple.
Yeah. UPSC, create route users.post.ts. It just maps the HTTP method from the file extension. It drastically reduces the need for manual route configuration files. You just organize your code logically in folders. And it still supports dynamic parts in the URL, like users.ad. And you can add middleware and route rules easily. It's flexible, but start simple.
That feels much more natural. Okay, performance. Always a top concern for backends, especially when they scale. Does Nitro offer specific help there beyond just being built efficiently?
Absolutely. It tackles performance head-on with built-in caching features. You can configure caching for specific API routes or patterns of routes right in your config, set how long responses should be stored, and it integrates seamlessly with unstorage. Remember the UnJS ecosystem. Unstorage is another piece.
Right, the storage layer.
Yeah, it's a universal key value storage API.
Yeah.
Supports over 20 drivers, Redis, local files, Vercel KV, Cloudflare KV, whatever you need. Makes your caching layer super adaptable. And this unstorage layer also, kind of quietly, powers Nitro's hot module reloading, HMR.
Ah, for development.
Exactly. This is fantastic for dev speed. You change your server-side code, hit save, and the changes are injected without a full server restart.
Okay, that's huge. No more waiting 10 seconds every time you tweak something.
Precisely. That immediate feedback loop, massive productivity booster during development.
Right, we've heard about all these cool features, but how does it feel in practice? Our sources gave an example of building a simple to-do API. Can you kind of walk us through how that might look using Nitro?
Yeah, that example really shows how practical it is. Let's say you want a GET to-dos endpoint to list all to-dos. You'd make a file, maybe abidosindex.get.ts. Inside, use defined event handler, like export default defined event handler, simple. Want to add a to-do, that's post todos. So abidosindex.post.ts. Inside that handler, you'd probably use read body event to get the JSON data sent by the user. Safely parses it.
Makes sense. What about specific todos, like update or delete?
Right, so pottodos.id or deletettodos.id. With file system routing, that becomes something like apidosid.put.ts. The brackets signal a dynamic part.
Got it.
Exactly. And inside that handler, you use getRouterParam event to grab that ID value from the URL. Then for saving the data, use storage. You can tell it to use, say, a local file system stored during development via unstorage, maybe in a .dotv directory. So you'd use storage.todos.setItem or getItem. So you see, you can implement full CRU'd, create, read, update, delete, really quite directly. Error handling, persistence, it all fits together nicely.
And then the final step, getting it online. Usually where things get complicated with cloud configs, does Nitro keep things simple for deployment too?
It really tries to. So while you might use local file storage for ustorage when developing, for deploying to, say, Vercel, you'd switch the storage driver. You'd add the @Vercel v package, for example. Then you just update your nitro.config.ds to tell unstorage to use Vercel KV when running in production.
Is it just a config change mostly?
Yeah, pretty much config driven. The actual deployment uses standard Git, standard CI/CD. You push your code. Your platform, like Vercel or Netlify, detects it's a Nitro project. That zero config auto detection helps here. And then Nitro handles bundling your code correctly for serverless functions, edge functions, whatever the target is. Now, the sources do mention, sometimes you hit those inevitable weird cloud provider quirks that can happen. But Nitro itself aims to make the core bundling and deployment part as smooth as possible across different environments.
That's a really compelling story from dev to deploy. But okay, reality check. One source mentions some pitfall experiences, specifically around docs and the learning curve. Always a thing with fast-moving tech, right?
It absolutely is. And it brings up that key question. How do you actually learn this stuff effectively when it changes so fast? The sources point out that while Nitro is powerful, its own standalone docs might feel a bit sparse sometimes, especially for, the deeper, lower-level APIs.
Okay.
So say you need to set a specific HTTP header or content type, and you can't immediately find it in the Nitro docs. The crucial insight, the big tip, is remembering Nitro builds on H3.
Back to H3.
Exactly. You often need to go look at the H3 documentation, especially its utilities section. That's where those lower-level HTTP manipulation functions live. It shows how interconnected UnJS is, which is good, but it also means the learning path sometimes involves digging into those foundational layers. You got to know where to look.
That's a really practical tip. Good to know. So beyond learning, there's always optimization. Getting peak performance. Our sources had some advice there too for getting even more out of Nitro. What were some of those?
Yeah, definitely. Nitro's fast out of the box, but you can always fine tune. A lot of it comes down to good JavaScript practices, really, like trying to avoid dynamic types when possible. Helps the JavaScript engine optimize. Also, reducing unnecessary object allocations. Creating tons of temporary objects adds overhead.
Right. Basic JS hygiene.
Pretty much. And making sure you use async promises for anything potentially long-running so you don't block the main thread handling requests. Then there are more advanced things. For really large data, using array buffer can enable zero-copy memory sharing.
Zero copy.
Yeah, instead of copying big chunks of data around in memory, you're sharing direct access to the same memory. Much more efficient for binary data or large payloads. And another interesting idea was implementing hybrid objects for lazy data access.
Lazy data access.
Imagine a huge object from a database. A hybrid object acts like a proxy. It only fully processes or loads the data for a property when you actually try to use that specific property.
So you don't process everything up front if you only need one piece.
It's exactly. Saves potentially a lot of processing time and memory, especially if you only need a small part of a large data structure. It's about being smart with resources.
Okay, so we've covered a lot today. What's the big takeaway here for you, the listener, trying to make sense of the web development landscape?
We've really dived into Nitro, seen how it aims to simplify server-side JS zero config setup, that amazing universal deployment capability, and strong developer experience features like auto imports and HMR. It's clearly a key part of this growing UnJS ecosystem, and it's proving its value beyond just N2P. Next, other frameworks are looking at it now too. It really highlights, I think, the power of open source collaboration and this constant drive to innovate to make building complex things simpler and more efficient in the JavaScript world.
Yeah, it's clear Nitro and UnJS aren't just about building apps, but building them better, faster, with less friction, and maybe more freedom. So here's a thought to maybe mull over. As these kinds of universal tools keep evolving, blurring the lines between server, edge, even browser runtimes, how might they reshape our whole idea of full-stack development in the next few years? What new kinds of applications or architectures become possible when the back end becomes as adaptable and, well, as friction-free as the front end aims to be?